Welcome to this National Blockchain Network Zanzibar Blockchain Awareness Program. This is week 2, day 2, right? And so far, we have covered different aspect of blockchain. We have also covered like what is blockchain from a layman perspective, and then we also try to understand what is the benefit, what is the some of the features that makes it very unique technology, right? As a technology that we have tried to understand that. We have also covered some of the use cases, different types of blockchain, right? Uh, Today we are going to talk about again some basics of blockchain from different perspective, right? And at the same time, how it is going to help as a technology to make the public services more efficient. Okay. So thank you. Thanks for joining this session. And uh, let me start with this, right? So quick question. What is blockchain? What comes into your mind? Last time also we have asked this question, but I just wanted to understand what comes to your mind when you hear this blockchain as a term. Hamza, you can type your answer also in the text chat here, or you can unmute and talk. If you don't know that also, that's okay, fine. That's perfectly fine. We just wanted to see that what is your understanding, how you are able to correlate with your understanding. Okay, anyway. So Uh, usually, when we talk about blockchain, we think about crypto, we think about Bitcoin and all. But here, when we are talking about blockchain, it's merely a technology. It's a technology that permits a transaction to gather into blocks and get recorded. We have talked about some of the features like it is a decentralized, distributed, immutable, secured, and all, right. But if you look at what we are trying to achieve with this blockchain, we are just making sure that the transactions which is coming up, right, it's able to gather, and that is in the block, and chain that block and record it. Okay. So at very low man, you can just imagine like all those transactions we are maintaining into a ledger, right? So that is what we are talking about. And what it does, it cryptographically chain the blocks in chronological order, right? So what happens in that case, all your transactions are having an order, and that's very important. That makes it as immutable, that if you are changing those uh, order, right, it will not accept it, right? It will be able to find out that there is a some manipulations happening. Somebody wants to try to make or break that chain, right? And cryptographically, how it is being done in our week one, day one, day two, Tibin was there and he has explained about the encryption, decryption, hashing, and all those things. We will talk about those terminology a bit here also, right? But we'll see. And it allows the resulting ledger to be accessed by different servers, right? It is not like a from one server or one entity it is going to be accessed. It is going to be from the different servers, different nodes, you can say, right? So what we are talking about here, that maintaining a ledger, right, or each transaction as a block, which will be linked or chained in a chronological order, and it will also use that cryptography to make it more secure, and it will be on the different servers, right? This is what we are talking about as a blockchain, and it's just a technology. What use case we are going to build on the top of this technology is completely up to us, right? I will also talk about a bit on the different type of blockchain that we use. Usually, when we use that word blockchain, it is treated as like a public blockchain, and there is something called as private or permission based, right? So we'll talk on that line a bit later. But at this moment, I would suggest like you just understand that what is blockchain, where we are actually maintaining a ledger, which is a transactions gathered in blocks, recorded, and it is chained, all blocks chained together with cryptographically, right? And this all ledger will be maintained at the different servers. So we are talking in short is a decentralized and distributed ledger, right? So let's try to understand what is decentralized and what is distributed. And when we are combining these two things together, how it becomes more powerful. So usually you just imagine if you are going to a bank, if there is a bank which is a central entity, right? It maintains a different type of ledger for different user, right? So if you look at this diagram, right? So here we have that in the center, this bank, which is having a client A ledger, client B ledger, client C, client D, and client N, right? And number of ledgers, which is maintained by the bank. Now, if as a client B, you feel there is a discrepancies between the ledger, then what you have to do, you have to approach the bank and you have to convince them, and then only that will get resolved, right? So if you look at, even though we have the multiple ledgers, right? But bank holds the golden record. He says that this is what the right record that is with us. And if you find any discrepancies, you have to convince bank of that your true state of your ledger, and any discrepancies arise, right? So that is called as centralized ledger. All the ledger maintained by this bank, right? Okay. Now, when we say that decentralized ledger, what happens in that case? There will be different set of nodes like A, B, C, D, E, any n number of nodes, right? Each node will have some level of access to that ledger, right? And whenever there will be a protocol, right, which all node will agree, right? So whenever a new transaction comes, it got verifies here and it gets a consensus from every node, right? And then that transaction is getting accepted. So now there is no way of like, okay, only node A can just say that, okay, this transaction is valid, or node B only can say that. So that centralized power is getting distributed to the different nodes. That is called as decentralized ledger. Are you guys okay with that so far? Or you need any question, anything? Charles, I'm seeing that you joined. Thank you. Thanks for joining. Are we clear so far with this? Okay. So next is that, okay, thank you. Next is the distributed. We are saying decentralized, we are able to see that. Now there is a distributed. Now distributed is something that we need to understand. Why? Because even in the bank, they can claim that we have the distributed ledger. Distributed data centers are there where it is getting maintained. It's not like a one server that is maintaining that, right? And that way they are also true, right? But when we are talking about decentralized and distributed, right, that is having a different meaning, right? So if there is a single entity, and that's where this box is there. If you look at, there is a box that represent a single entity which maintains all the servers or nodes within that box. They will be also like in the bank also, it will be not like a one server which will be maintaining everything. They will be also having that multiple servers, multiple data centers, right? Distributed. to the different locations, geographical location, to make sure that they have that better disaster recovery and all those kind of things, right? They will be able to see that in the worst situation also they are able to run their business. So distribution things will be there, but if you look at here, it is with the one box. That means it is still owned by single entity. Whereas when we are saying it as distributed ledger in terms of the decentralized, right? Then you will find that each box is a different entity. Node A is maintained by someone else. Node B will be maintained by someone else. There could be a situation where two nodes or multiple nodes are maintained by one entity. That's okay. But still, if you look at it, is more distributed, right? It is not owned by a single entity. It is owned by the multiple entity, and that's where it makes this technology more powerful in terms of the trust and credibility. Okay, so hope you guys are clear with the decentralized and distributed. If I'm just looking into the previous, right? Here we are talking about centralized and decentralized, right? Which make it quite clear. Okay, and when we are talking about a distributed, right? So this is also named as distributed or distributed decentralized ledger technology, DLT. We use that word also for blockchain, right? So how this distributed ledger actually work, right? And how any transactions will be uh, uh, introduced and accepted. So what happens whenever any user initiate a transactions using their digital signature, and that is where we were talking about encryption, decryption, and all, right? Which we have talked about in cryptography uh, session, right? So user initiate transactions using their digital signatures, which makes sure that it's a uh, like a good transactions, right? And then what he does, he you broadcast their transaction to nodes. So whenever he enters, it goes to the different nodes. One or more nodes begin validating each transaction, right? And then node aggregate validated transactions into blocks. It put into a blocks. Nodes broadcast blocks to each other. And after that, there is a different consensus protocol is used to determine that this transaction is valid and can be accepted, right? And the consensus is they're having a different kind of algorithm, like proof of work, proof of stake. There are different POS, right? DPoS and all, right? People uses that. And based upon that, it is getting, that block is getting accepted, block reflecting true state is changed to prior block. Previous block, it is getting changed, and that's how it is going to be accepted. And if you will try to validate this with any node, you will get the same result. If you look at the same thing, I will try to depict in a different diagram, right? So someone requests a transaction, right? The request transaction is broadcast to a P2P network consisting of computers known as nodes, like a different nodes are there. Then what happened? A verified transaction, right? uh, which involve the cryptocurrency contract records, other information is coming to here in this, right? And everywhere, if they have the consensus, right? Once verified, the transaction is combined with other transactions to create a new block of data for the ledger. And then whatever we are seeing here is nothing but blocks, which is chained. The new block is then added to the existing blockchain. And that's the reason it's called as blockchain, right? And in a way that it is permanent and unaltered, and the transaction is complete. Some see, I will tell you, this looks like a little what you can say very straightforward, but I will tell you this part when it is getting verified, consensus mechanism is used, is creating it's a time consuming thing. It cannot be done very fast, right? If you have lots of nodes and all, right? That is another reason when we say that blockchain will have one issue on that, can it be a fast transaction, can it be, But I will tell you, we have to look at like what we want to achieve. Slow does not mean that it will be very slow, but yes, there are different kind of algorithm, then different kind of optimization people are coming up and they are improvising that, right? That is always there. But another thing is it, again, if you we are looking for the current way of like having that handling the transactions, it will be little slower. But we have to look at what we want: trust, credibility, or we want fast or something like a not so credible. So it all depends on the what kind of use case is there, right? And based upon that we can think of, right? The another thing is it's important to understand when we were talking about it will create a block. If you look at this green, yellow and all, right? Yellow is something new has been added there, right? Each block will be having certain structure. So if you look at block will be having a header, right? Has a previous block, right? And that's how it is getting changed, right? Timestamp will be there. There is something like a non, we will talk about that in detail bit later, right? Not in this session, right? Then Merkle root and all, right? That that will be giving them that how these transactions are having a link, right? All these transactions, 1 2 3 4 and all, right? And then the transaction data. So you just understand one is like a hash of previous block. And if you remember when hashing was getting explained, each time when you are giving any data there, right? The hash will be completely unique. It will be always different, right? So if you are going to change anything, right? Suppose here, right? This hash will get changed. And if you will send that kind of block there, right? They will be able to know that is not matching with the previous. That is one of the powerful thing which is making them like a more trustworthy, and like it will be it becomes more immutable. If you want to change anything on these transactions, right? You have to create another block which will nullify this transaction. It's just like financial ledger when we maintain. And when you add any record by mistake also, your system will never allow you to modify that. Once it is accepted, it's recorded into the system. Next, what you have to do to make sure that that transaction will get nullified, you have to again add a new transaction stating that the previous transaction is going to be nullified, and that region you have to say. Like suppose something has been credited by mistake in the system, then you have to just put another transaction for debit and you have to put the note on that side. So your previous record is always immutable. The same thing works in case of blockchain also, right? So this is what the block structure is. In subsequent session, we will actually go through a little deep dive on these structure and other things as well, even the Merkle root and Merkle tree also. So far, any question?
It's Mr. Vinay. I have a question. Hello.
Ye- Yes, please.
You've talked about the validation that every node need to validate a transaction that have been initiated by a user. My
Right.
question is, maybe if you have maybe thousands nodes, does it necessarily that all nodes need to verify or to validate those transactions, or there are group of nodes who are which are actually designed to validate that kind of transaction? That's the first question. The second question is, you've talked about the hash of previous block, hash of the next block, and the next block, and the next block. Does the hash need to change also, or it's just the hash calculation remain the same? Maybe have a transaction from user one. Uh, maybe I don't understand about the hash here. You said that the hash from previous block, hash from previous block, that the hash need to change too from block to block, or the hash need to remain the same? Thank you.
So your first question is, uh, does all nodes? verify the transaction in case of this blockchain, right? That is what your question is, right?
Yes, yes, yes.
Right. So there are different type of nodes also, right? Not all nodes necessarily verify every transaction. So there are different type of nodes. There are nodes which is a full node, right? So which maintain complete copy of the blockchain, because over the period of time, you if you look at your entire block and all those things are getting added and getting increased and increased, which will require lots of storage and lots of things, right? So you find that there are some full nodes, right? And there are something which is a lightweight nodes, which will not actually rely on a full node to verify the transaction, right? But it will used in a resource constrained device, like, okay. Then there are something which is a miner or validator nodes, which is specific to the consensus mechanism. Verify and propose the new blocks by validating transaction within those blocks, right? So if you'll ask me, for all nodes there are different purpose of nodes also which is being used, and there are some certain nodes who are actually used for the validator, like miner and all those, right? So that way it is designed, right? But still it will be a like a different algorithm. If you look at like a POW, proof of work is there, miners will be having to complete the solve some kind of computational puzzles and all, right? So that way they will be able to do that validation of that. The proof of stake will be some validators which will propose or confirm blocks based on stake and random selection, right? So there are different way to handle that. But to answer your question, not all nodes are done for that. But yes, of course, there are different algorithm being used where different type of nodes participate into that. And your second question was, can you repeat your second question? Sorry, I missed that. That was related.
You okay? You explained about hash calculation
Right.
from different block, actually, maybe block 0, block 1, block 2. My
Hmm.
question was, is the hash the same from each block, or the hash need to change after the transaction has been performed, or validation has been performed, which have been initiated by the user, or the hash remain the same from all the blocks? That was my question.
And so hashing techniques will remain same, and it will be always like will calculate like a previous blocks has, right? And that way it will be used, uh, right? But at the same time, one minute. Let's see if, yeah. So Tibin, do you want to add anything here?
Yeah. So here, Charles, the thing is, each block, when we creating the block, it can consist of many transactions. So if you're taking Ethereum blockchain, it is creating the block in a few minutes, every 10 minutes, it is creating the block. So that it can contain few transactions. So based on the transaction, we are creating the hash. So like we are creating a Merkle tree. So for that particular block, that hash is permanent and it cannot be changed. Okay. So the hash is calculated based on the values of all the transaction in that block. So for the next block, so we are creating the transaction, users are creating the transaction for the 10 minutes. And then we are again creating, doing the proof of work and all the transactions are validating. Then we are calculating the hash of those set of transaction. And then we are using the hash of previous, that means the first block. So total we calculate the hash of the new block. Okay. So then the third block will be begin. So those things are done by the minus. So for each block, there will be a hash, and the hash is calculated based on the transactions of that particular block. Okay. Is that the question?
So that means each block has its unique hash
Yeah.
calculation, right?
Yes.
Okay, thank
Yes.
you. Thank you so much.
Okay, fine. So, some important facts of blockchain technology, I would say, right? That it is a type of ledger which contain information about transactions, right? That is something we need to understand. Okay. Second is each transaction generates a hash. So transaction hash, that's what we usually say that, right? Hash is nothing but it's a string of numbers and letters, right? Transactions are entered in the order in which they occurred. Order is very important, right? Then the hash depends not only on the transaction, but the previous transactions hash, right? Even a small change in a transaction creates a completely new hash. So that is the reason we say that the moment we'll do it, right, it is like a very difficult to make a change into any previous one. Then the entire structure is going to change. And if the entire structure is going to change, then no node will be able to validate that, right? Or you have to take a control of all the node. That is a region, it's decentralized and distributed. So not a single person is owning that he can be able to make the changes there, right? And the nodes check to make sure a transaction has not been changed by inspecting the hash. So it always look into that. Okay. And if transaction is approved by majority of the nodes, then it is written into a block. And finally, each block refers to the previous block and together make the blockchain, right? That is what it is. Okay. So this is very important to understand this, how the blockchain works, right? Now, there are few things which I want to go to the next level of, because we are talking about blockchain, and that is also we are talking about in public services, right? And that means we are talking about government services, right? Now, in my previous session, right, we have touched base on the public and private blockchain. The public blockchain is going to be completely decentralized, right, and distributed. That means no one owns, right? Not there is no single entity, right? And there it remains completely open for everyone, right? So anyone can come and participate. Whereas permission based and private, when we are talking about, still it will be having a decentralization distributed in certain way to manage, but it will be not open for everyone. There will be always a regulation. On that basis, somebody will get accepted, right? Even the nodes can be distributed among different ministries, right? Different financial institutes, right? Sometimes with the private enterprises also, right? That can be done, right? So that way, no single entity will be owning that node. That is there, but still, when we are talking about government and all, right, they have to make sure that there is no like a regulation and compliance has been overlooked, right? Because that way it's not good for any public services, right? So that we have to understand that when we are talking about this way, right, we are definitely talking about something which is related to the public and the private thing, right? And this is very important, right? Because permission blockchain is nothing but it's a private network, right, where only authorized participants can join and participate, right? It will have certain restricted access because they want to make sure that the people who are going to use or the entity who are going to use are uh, adhering to that compliance and regulations of that country, right? So that is what I wanted to highlight before we'll go to that. So why government will look into the blockchain technology for their services, right? The first challenge is, if you look at most of the places we are saying seeing that they are either manual processes, right, which lead lots of inefficiencies, right? We have lots of things where you need a printed copy, documents, hard copies, and all those things are happening there, which is moving from one department to another department and all, right? So we are talking about something which can be automated, digitized. And then another one is fraud and errors in record keeping. Even though they are digitizing, is it uh, prevailing this fraud and error? If it is not, right, that means there is it giving a chance to have a corruption there also, right? So if blockchain is coming into a picture as a technology for those services, right, that will give more transparency, credibility, and trust, and less chance of, or no chance of fraud, you can say, right? If we know that this document has been originated from here, after that you cannot make any change. If you are making any change, you are coming up with a new, right? And that people are able to keep a track also, that previously it was there, it was this, and now it is this because of this region, right? So blockchain is going to be a solution for those kind of place where it can automate workflows, which will reduce that reliance on paper, hard copy, or manual things, right? And then it will create a single source of truth for data. If you are getting a one like a document from government, how can you ensure that it was really you got it from the government? Or if you got any kind of fine, any kind of like a fee, right? Any kind of tax related document from the government, how you will ensure that the document is actually came from the government, right? Blockchain will be the answer for those kind of things, right? You can easily be able to track it out, like, okay, this is originated from here, right? Like imagine tax filing processed instantly through a blockchain ledger, reducing delays and errors, right? You will be able to backtrack also, right? So blockchain for government, right? It's transforming public services by transparency and accountability, right? That is most important part. Then efficiency and speed. Why? Because manual process is always not efficient, and it always delays the things, right? Cost savings, because it will reduce the operational cost. For manual thing, you need like a lots of things, right? And I'm talking about like it will create the different kind of jobs, but not for the manual thing, right? And data security. Your data will remain secure, right? So that is something very important for government, right? So one of the thing is like a public administration, right? If we are streamlining that government operations, right? So suppose we are implementing that in the procurement. So what will happen? Everything will get recorded on blockchain. It will get verified all stages of government tenders, contracts, everything. It will be more fair and transparent, right? That is going to see the biggest challenge with the government is building the trust, right? And the moment it's becoming more transparent, the trust is automatically will come there. The second is like a digital record keeping. Government documents, licenses, permits, contracts, everything will be like managed through the blockchain. Not exactly stored there, but yes, of course, that transactions, right? This, what is the documents origin and all those things, right? Everything will be coming there. Because just imagine, blockchain is not a database, it's a maintaining a ledger, right? So yes, digital record keeping, that information, everything will become immutable and all, right? So we can be able to see that, right? The third one is like subsidy distribution. If we are providing any kind of subsidy to any kind of citizen, right, who are eligible, different groups, different categories, right, all those things, we will be able to see that the distribution is fair enough, right? It will reduce the fraud, increase the efficiency. As a citizen also, they will have more trust. Yes, this is what I'm able to see. And the last one is like a regulatory compliance, right? If any real-time audit, compliance, all those things are required, it will be much easier if it is on the blockchain, right? One more thing I will just touch base, right? The healthcare. And this is very important. The healthcare, if you look at, the biggest challenge with the healthcare sector is uh, maintaining and securing that all electronic health records. That is the first one. And that is where you will find that most of the places where it's a government or the enterprise, they are having a challenge to have that like a restrict that data breaches and data leaks, right? So if it will be all on the blockchain, you can find out like, okay, it can be more secure, right? It will ensure that patient privacy as well, right? Only that authorized people will be able to see because of the encryption, that public private keys pair that we are maintaining. Then hashing, it will be maintaining like, okay, data is immutable. So all those things will make that EHR records maintaining easier but more secure. Similarly, if you look at like in healthcare, there are multiple use cases. Drug supply chain management, we have seen that supply chain management can be more transparent and secured, right? If we are using that blockchain as a technology there. Insurance claims, that is also another place, right? Which we can see that how smart contracts, blockchain, all those things will be making that like a more efficient, right? Verifying insurance claims, reducing processing time, right? Overall, it's going to minimize that fraud, right? And pandemic management, even we have seen like during the pandemic, right? Entire world they were looking for like how they can be having a better way of sharing that real-time data, right? Because even though it is required, it is again having like a patient privacy and all, right? Those things can be maintained that, and tracking of all vaccine distribution and everything, right? If we are going with this blockchain kind of solution, right, it is going to be more efficient and effective, right? So I was talking about this, right? Government require permission-based blockchains. Last session also I have touched base, right? One is like it can give a better control and governance, right? Data privacy and security, scalability and performance, compliance and regulations. They can add it here because it's permission-based. It's not like a permissionless, right? Integration with existing infrastructure. And I will tell you, compliance and regulation is becoming a challenge for the even the for the public blockchain also. They are also looking at like, because that's how the different country it will get adopted, right? Integration with the existing infrastructure, fraud prevention and identity assurance, right? And those are the things, right, which will be making it as like, okay, why they will go for the permission based, right? Because that way government will also feel like they are actually not doing anything which is uh, not good at the country level, right? So future of government, that are how they can embrace that blockchain innovation, right? How they can create this kind of awareness, and that is what where we are having this kind of sessions with uh, within the different groups, right? Let them aware of what is blockchain technology all about and how they can embrace that, right? How they can collaborate between different government agencies, industries, players like a key private sector, right? Technology expert, right? And another thing is invest in terms of like they have to do some R&D, they have to do some POC, right, to build that robust blockchain ecosystem. And another one is empowering the citizens to participate in this blockchain ecosystem. Right now, the if you look at the Zanzibar government, they are doing lots of things on this side, right? Very soon in coming week, maybe you will get some more information also how it is going to happen and how it's happening, right? All those things, right? Stay tuned, right? Be a part of. It's just a start, right? We are just hearing, talking, and all those things. It's just a start. You will very soon you will start seeing some of the applications coming up, right? Because of some startups whom we are collaborating. some of the top-notch R&D centers we are collaborating in that case, right? We are partnering with some of the best institute in the world, right, who can help us also to create that kind of innovation center within Zanzibar, right? So yes, there are lots of things which I'm seeing right now, and definitely you people will be able to realize that very soon. So that's all from my side for today, and I would like to have some questions from you guys, right, that we can answer. We have some more time, 5-10 minutes, and we can discuss. So, Pharmacia and Charles, any question? If you have any question, you can ask now or write into the chat window. Else, you can, I guess you guys are part of that Telegram group also. There also you can write down, or you can directly write to us on nbn@egas.go.tz, right? You can write a mail to there, and definitely the support team will be responding to your questions, your queries. Anyway, every week we are having a couple of sessions planned. Next session will be on Friday, so we will be able to get that. Okay. Telegram group. Okay, a link. I will just share 1 minute. Yeah, I just provided you, Charles.
Thank you so much. I have a question.
Yeah, Charles.
Uh, from the last discussion from what you have already covered here, you actually explain about the advantages of blockchain technology that the government should embrace. Actually, there are so many features, there's so many advantages, like security and so far, data privacy, scalability, compliance, etc. But and actually, the user is the one who actually have access to those informations. Maybe he or she want to go to hospital. Uh, he is the one. I mean, the patient is the one who can have access to those informations. Uh, my point is, there is no any other way that those credentials that are used to enter those systems to access certain data to be tracked and hacked in the process or intermediate. Maybe for maybe the user they are using fingerprint or face unlock to access those data. Is there any mechanism that a hacker can have access to those credentials which are used to enter, so that those data of the patient can be accessible? That's my question.
Okay. So what you are saying is, if a hacker will get access to those servers or those data side, right? Whether he will be able to access the data or not. Is that the question, Charles?
Yes, before the data been before the data has you said that the blocks several blocks or million blocks has to validate those transactions or those data. Maybe transaction to allow a user or a patient to access their data. My point is that before those credentials are going direct, before those credentials are actually uploaded to one of the blocks and the other block and the other block to be validated. In between, before those that have been transferred to the block, can hacker have an access to track those credentials before even the validation uh, has been occurred?
Right, right. So as I told you, right, there will be also the data will be cryptographically secured, right? So with the encryption and decryption keys, right, what we are talking about will also be used to encrypt that, and to decrypt that particular data. They definitely need those private keys. So that way, it will not be possible for them to make the change. But still, I would like if Divin is here, if he wants to add anything on here. On,
Yeah. So I think the Charles question is before adding to the block that any hackers can take that data. So the thing I want to say is, Charles, actually, in the case of if we are checking with the Bitcoin, so we are doing the proof of work. So the thing is, only the miners are able to access the transaction which are not committed into a particular block. Okay, so if you are assuming a hacker come in as a miner, it is we are saying it is a practically difficult thing to become a miner, or not a practically difficult thing. We have to find lot of resources to become a miner. Okay, so but the none of the hackers will do that thing, and as well as we have to we have to do this proof of work. Okay, and only the miners who is able to having the resources to complete the proof of work will be able to validate the transaction and add it in the blockchain. So our main thing we are saying is it is not possible for a hacker, or we cannot say a hacker won't come into that state with a lot of resources for making a mining. Okay, and if you are thinking about after adding it into the block, we are with the help of smart contract, we are actually validating the users who had able to access the data. Okay, so we can do that thing also. Yeah, that's it, my from my side, Charles.
so to answer your question, Charles, right, it requires when Divin has told more resources, that means definitely for one transaction, right? How much cost he is having, that matters a lot, right? And he never knows that what is there in that transaction, right? So usually that's the another reason. If you look at blockchain case, we are saying that it is like a unhackable. Why? Because the hacker has to put that much money just to get one transaction, which may not suffice for the return of investment for that transaction, if he is going to hack and do anything, because he will never know that what is there in that transaction, right? And if he has to put that much effort and multiple times if he is getting it, he will be always in the loss, and he requires to invest a lot. Like I will tell you one thing, like when we say encryption decryption, right, we use that one technique like AES 256, and usually we say that if it is AES 256 encryption done for one particular transaction or record or whatever, right, if somebody wants to break that, maybe it will take, in normal way it will take something like a 50 years or something. If he has to speed up, then what he has to do, he has to put lots of resources to make sure that he can be able to do that. And if he has to do that much effort just for one transaction, you just imagine so many transactions are there. It is literally not possible for anyone to do that, right? So that's the reason we say that those are very very like secured encryption techniques. Right. So same thing here also. He needs to put lots of resources, and lots of resources means more cost, right? And we never know what is there in that transaction that will worth actually of that much investment, right? Are you clear, Charles?
Yes. Understood. Thank you so much, Mr. Rene. Thank you so much, Mr. T.
Okay, so thank you. Thanks for today's session and joining us here. All right, we really thank to each one of you and hope to see you in the next session. Thank you.
Hii ndiyo Zanzibar ya kidigitali, Zanzibar